Let us look at proposition number 10 of works of Archimedes, specifically on the spheres and cylinders. So the proposition says, if in the plane of the circular base of an isosceles cone, two tangents be drawn to the circle meeting in a point, and the points of contact and the points of concourse of the tangents be respectively joined to the apex of the cone, the sum of the triangles formed by the joining lines and the two tangents are together greater than the included portion of the surface of the cone. So let's see how to prove this. Now, to make it more understandable, I'm going to, position it like this. So it will look like the center of the circle, but it is actually the apex of the cone. And these are the tangents. Let ABC be the circular base of the cone, O its apex. Draw tangents to the circle at A and B to the point of intersection D, and C be the point bisecting the arc ACB. So we bisect this arc AB at C. So let me mark that point C. Remember, the C is not on OD. It is on the circle. Join OA, already done it. OB, already done it. OD, already done it. Now draw a straight line ECF touching the circle at C and intersecting AD and BD. So let's draw that line and let's name this as E and this as F. Join OE and OF. Let G be the axis of triangle OAD plus triangle ODB over the triangles OAE, OEF and OFB. So you can look at it as a pyramid. So that OAD plus ODB is equal to triangle OAE plus OEF plus OFB plus G. Let L be equal to the EA. L is the sum of the areas between the circle and the tangents. So EAHC, this part and this part. Now ECF is going to be parallel to AB. ED plus FD. ED plus FD is greater than EF, because sum of any two sides of a triangle is greater than the third side. To left hand side and the right hand side, we are adding AE plus FB. AE plus FB to both the sides. So ED plus FD plus AE plus FB is greater than EF plus AE plus FB. Now here, if you notice, ED plus AE is AD, and FD plus FB is equal to BD. So AD plus BD is greater than AE plus FB plus EF, and OA is equal to OC is equal to OB, because they are all generators of this cone. OA is perpendicular to AD. OC is perpendicular to EF. OB is perpendicular to BD, because these are the generators of the cone and they are equal to each other. Now, triangle OAD plus triangle ODB is greater than triangle OAE plus OEF plus OFB. Why? Because the slant heights are same, right? Slant heights are same and they are perpendicular. So, which means triangle OAD plus triangle ODB is greater than, we replace it with equal to triangle OAE plus OEF plus OFB plus G. Now, G will be either less than L, the excess quantity here and here, or it will be greater. So, let's take it one by one. Let G be greater than L. Surface OAEFB, the pyramid, excluding OAB, is greater than the surface of the section of the cone OACB plus segment of the circle ACB. Why? Because they both have their same extremities and one is inside the other. Now, let us subtract segment of the circle ACB from both the sides. So, triangle OAE plus OEF plus OFB plus L, these two, is greater than the surface OACB. So, which means instead of L, if we take G, and since G is greater than L, that means triangle OAE plus OEF plus OFB plus G will be much more greater than the surface OACB, surface of the cone. So now triangle OAD plus triangle ODB is going to be greater than the surface of the section of cone OACB. Why? Because triangle OAE plus triangle OEF plus triangle OFB plus G is equal to triangle OAD plus ODB. So we are substituting this with triangle OAD plus triangle ODB. So that was our first part, because this is what we had to prove, that the triangle OAD plus triangle ODB is greater than the surface of the section of the cone OACB. Let us look at the other case. G is less than L. Bisect the arcs AC and BC and draw tangents at their middle points. Then bisect the halves and draw tangents till we arrive at a polygon such that the sum of the parts remaining between the sides of the polygon and the circumference of the segment is less than G. So let's do that. By the way, H and K is what I had done, the midpoint of these arcs AC and BC. So now let's draw the tangents. So this is P, this is Q, and again here P, Q, R, S. These are the points we get when we do this. Let the remainder be the sum of the segments of the circle M. Sum of the segments is M between the circle and the polygon APQRSB. So it's not visible, but remember there is a circular segment here between the polygon and the circle. So this plus this plus this plus this is M. Join OP, OQ, OR, OS. OB is already done, so we don't need to do it. So now triangle OAE plus OEF plus triangle OFB is greater than OAP plus OPQ plus OQR plus ORS plus OSB. Why? Because again, the extremities are same and one is inside the other. Now, surface of pyramid OAPQRSB excluding OAB triangle is greater than the surface OACB of the cone plus segment of the circle ACB. So here on the right hand side, we have the lateral surface area of the cone plus the bottom segment of the circle AC. And here surface of pyramid also has the sum of these areas of the polygons, plus it also includes the polygon APQRSB. So, which means if we subtract the segment of the circle ACB from both the sides, what do we get? We get triangle OAP plus OPQ plus OQR plus ORS plus OSB plus M. How did this M come suddenly? Notice this APQRSB. This segment has been removed. So what are we left with as far as the bottom of the pyramid is concerned? We are only left with these small segments left out, which sums up to M. And on the right hand side, if we remove the segment of the circle, we are only left with the lateral surface area. So now triangle OAE plus OEF plus OFB plus G is greater than the triangle OAP plus OPQ plus OQR plus ORS plus OSB plus M. So, which means we can say triangle OAD plus ODB is greater than the lateral surface of the cone. And basically what we are doing is substituting OAE plus OEF plus OFB plus G with OAD plus ODB. Because remember here we have triangle OAE plus OEF plus OFB plus G is equal to triangle OAD plus ODB. So, which means we have completed the proof of proposition 10 of works of Archimedes, specifically on the sphere and cylinder. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.